Welcome to qnawire.
In this problem that our second derivative f double prime of x is continuous for all real numbers, or from negative infinity to infinity. And in part A, we're told that f prime of 2 is equal to 0, and f double prime of 2 is equal to negative 5. And we're asked, what can we say about this function given this information? Well, since we know that f prime of 2 is equal to 0, that means that we have a critical point at x is equal to 2, which means that at x is equal to 2, we could have a local maximum or minimum value. And since we know the sign of our second derivative at this point, x is equal to 2, we can tell whether this is a maximum or minimum. Since this sign of our second derivative at x is equal to 2 is negative, so since second derivative at x equal to 2 is less than 0, that means that this is a local maximum. So we know that we have a local maximum, and this is from the second derivative test at x is equal to 2. If the second derivative was greater than 0, then it would have been a local minimum. So what we can tell from f prime of 2 being equal to 0 and f double prime of 2 being equal to negative 5 is that we have a local maximum at x is equal to 2. And now for part B, we're told that f prime of x, or f prime of 6, is equal to 0, and f double prime of 6 is also equal to 0. So we know that there is a critical point, since our derivative is equal to 0, at this point x is equal to 6. So critical point at x is equal to 6. And since our second derivative at x, or at 6, is equal to 0, that means that this isn't a local maximum or a local minimum. For it to be a local max or minimum, this double prime of 6 would have had to been positive or negative. But since it's equal to 0, that means that this point at f double prime of x, or f double prime of 6, could be an inflection point. So potential inflection point at x is equal to 6, but it is not a local maximum or minimum since our second derivative isn't positive or negative.